All right, today we're going to be learning how to write polynomials. We're going to learn how to write them in factored form and also how to convert them to standard form. We do this by getting when you have roots given to you. So the first thing we have to do is a complex conjugate theorem. This states if a plus bi, so that complex number, is a root, of a polynomial, then its conjugate. Remember, conjugate means you change the sign in between. So a minus bi is also a root. And the reason this is because complex roots always occur in pairs. So if you know you have one complex solution, you actually have two, because they have to come in sets of two. All right, so that's the complex conjugate theorem. We're going to utilize that when we are given roots. So our first example here says write a cubic polynomial in standard form, all right, with a vertical stretch of 2 and with the roots x equals 1 plus 3i and x equals negative 5. So when you're doing a problem like this, you first want to figure out what we're looking for here. So it tells us it's a cubic polynomial, which means that we're going to have 3 different answers here. It has to be in standard form, so it has to be in decreasing order of exponents. Our leading coefficient is going to be 2 here because of that vertical stretch. And they give us 2 of the roots. So I'm going to list out all of the roots. So the first root is x equals negative 5 there. Then we have x equals 1 plus 3i. And using that complex conjugate theorem, I know that x equals 1 minus 3i is also a solution. So when I check this, I've got 1, 2, 3. So I've got my 3 solutions for my cubic polynomial. So we're good to go. All right, and again, we assumed this due to the theorem we stated beforehand. What we're going to do is we're going to take all those roots and we're going to put them into factored form first. So we're going to say f of x equals, in factored form, you put your vertical stretch out in front, so 2, parenthesis. And what we're going to do is we're going to unsolve for x here. So if I were to move this negative 5 over here, all right, that would become x plus 5. Over here, I'm going to move the 1, so it'd be minus 1, and move that 3i, so it'd be minus 3i. Over here, I'm going to move this 1 over, so it'd be x minus 1. I'm going to move that 3i over, so it'd become plus 3i. And now what we're doing is we're going to start distributing all this out. You can kind of take it step by step here. I'm going to distribute these 2 together and these 2 together and then combine the 2. So this first one, if I distribute that 2 through, I get 2x plus 10. Over here, this is going to take us a little bit of time here. X times x is x squared. X times negative 1 is negative x. X times 3i is 3ix. All right, negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times 3i is negative 3i. And finally, negative 3i times x is negative 3ix. Negative 3 times 1 is positive 3i. Negative 3i times positive 3i would be negative 9i squared. Whew, that's a lot there. So we need to kind of go through this and we need to simplify some of this down. All right, so when I do this, I've got the x squared, and that's my only x squared there, it looks like. My x's, I've got negative x, and that's it. So negative 2x. My 3ix, I've got a positive 1 and a negative 1, so those were reduced down. I've got a negative 3i and a positive 3i, reduced down. And over here, I've got the 1 and the minus 9i squared. Now remember that I squared actually means negative 1. So right here, this negative 9 is actually going to become a positive 9. So 9 plus 1 is 10. Now I can distribute this around, so I'm going to do 2x times x squared. That's 2x cubed. 2x times negative 2x is negative 4x squared. 2x times 10 is 20x. 10 times x squared is 10x squared. 10 times negative 2x is negative 20x. And 10 times 10 is 100. Combine like terms here. I only see one x cubed, so it's going to be 2x cubed. X squared is about negative 4x squared and 10x squared, so that gives me 6x squared. 20x and negative 20x, those go to 0. And then I have that plus 100. So I would say f of x equals this function. And we're good to go. All right, my second example says write the quartic polynomial in factored form such that f of negative 2 equals 10. So we've got a quartic polynomial, which means that we're going to have 4 roots. They want it in factored form, so they're going to have us keep it in this form here when it has all of the factors. Okay, so we've got to figure out what those are. You notice it does not tell us what the vertical stretch is, so we might have to figure out that self. So when I'm looking here, I want to be able to list out all the roots by looking at this graph. All right, so my first root happens right here at x equals negative 4. I have another root at x equals 0. And this one's a unique one. If you remember, when you have a root that touches that x-axis and bounces right back off like it does here, that's actually an even multiplicity. Okay, and this one's actually going to be a multiplicity of 2. So this is a multiplicity of 2. Because it bounces off that x-axis and doesn't actually go through it. And then my next one is going to be right here at x equals 3. Okay. Since they want it in factored form, it's going to look like f of x. We don't know what the vertical stretch is, so we're going to put a here. My first root, if I move that negative 4 over, I get x plus 4. If I move that 0 over, it's just x minus 0. And since it's happening twice, I'm going to square it because it's, again, happening twice. If I move that 3 over, I get x minus 3. X minus 0, that's just 0. So that's actually just going to be x squared right here. And if it's just x squared, I'm going to move it out in front. So it's going to look like so we're almost there. Now we have to figure out what our actual a value is, and we do that based on the point they give us. So we're going to plug in the values. All right, f of x says it equals 10, so this is going to be 10 equals a. My x value is negative 2, so I'm going to plug in negative 2 to all of my x's. Negative 2 times 4, or negative 2 times 2, or negative 2 squared is 4. Negative 2 plus 4 is 2. Negative 2 minus 3 is negative 5. 4 times 2 times negative 5 is negative 40. Divide both sides by negative 40. I get 10 over negative 40 equals a, which reduces to negative 1/4 a. So I would say my final answer is going to be f of x equals negative 1/4 x squared x plus 4 x minus 3.